What's up, YouTube? Woo! Mr. King coming at you live from the studio. Here are the questions we have for today. Please pause the video now and answer them. Yep. All right. Announcements. There are 2 more weeks until spring break, and your grades will be final after spring break. So then your grades will reset for chemistry and your other classes. Next, today, you will be able to predict whether objects will sink or float based on their density. So for the classwork today, can you go to classwork, density simulation, and pull up the worksheet? It should look something like this. Put your name on it and your date. First thing you need to do, we have a man floating, reading a newspaper in the Dead Sea. Why is he able to float in the Dead Sea? Remember, the Dead Sea is very salty and very dense. Why is this guy able to float? 2, what might happen if you try to read the newspaper while floating in a normal pool? Yep, okay. Then when you're ready, can you go to this link? Click on it and then log in. Up here, remember your login. If you can't remember your login, you can either make a new account using this class code, okay? Or you can just watch the video and pay attention. We're doing density via comparison. Okay, question 1. Place object A into beaker 2, which contains a liquid with a density of 1 equal to density of water. What happens? So for this simulation, we have 6 different balls and 4 different beakers. Each beaker has a liquid with the density given below. So even though they all look like water, really the only one that could be water is this one, because water is the baseline. Water has a density of 1. So this one is probably water. The other liquids we don't know, but we do know the density. Today you're going to try and figure out what is the density of each one of these balls using the liquids and determining whether they float or whether they sink. So remember, if something sinks, like A here, if it sinks, that means it's more dense than the liquid. So if A sinks in 0.5, that means the density of A is more than 0.5. Remember that. That's very important. So if something sinks, that means it's more dense. The opposite is if it floats. If it floats, it's less dense. So right now A is floating, barely, but A is floating in beaker 4. Beaker 4 has a density of 2.5, so I know the density of A is lower than 2.5 because it's floating, so it must be less dense than the liquid. So I know it's more than 0.5 because it sinks, but also know it's less than 2.5 because it floats. Okay, that will help you on 1 and 2. So number 1 asks you to put the A in beaker 2. What happened, and is A more dense or less dense than beaker 2? Next one, dropped object B into beaker 2. Describe what happens and explain what that tells you about the density of object B versus object A. So I'm going to put B in beaker 2. Okay, so B is floating, A is sinking. So what happened to B, and which one is more dense, A or B? Next, scroll down. Now we're going to try and figure out the density of A without being able to measure its mass or volume. And I'm going to do that using the liquids, or here. So how you do it, I'm going to figure out what is the highest density fluid in which it sinks. And then I'm going to figure out what is the lowest density that object A floats. So A, okay, it sinks in beaker 1. So I know it's more dense than beaker 1. It also sinks in beaker 2. So now I know it's more dense than water. Does it sink in beaker 3? Yes, it does. So I know it's more dense than beaker 3. Does it sink in beaker 4? Let's see. No, it does not. So back to my question. What is the highest density fluid in which object A sunk or sinks? It sinks in beaker 3, but it doesn't sink in beaker 4. So 3 is the highest density that it can sink in. So I'm going to put 1.5 right here. Okay. Next, what is the lowest density fluid in which object A floats? Okay, it floats in this one. That's the lowest it can go. So A must be very dense. It sinks in this, but it floats in this one. So the lowest it can float is 2.5. So for part C, I'm going to give you a second. Try and figure it out. If I know it sinks in 1.5, but it floats in 2.5, where should the density be around? I'm going to give you a little bit. Try and figure it out. Think about it, and then I'll go over the answer in 10 seconds. Okay, so remember, if something sinks, that means it has a higher density. If it floats, it has a lower density. So I know that object A sunk in 1.5, so my number should be more than 1.5, and I know it floats in 2.5, so I know my number for A should be less than 2.5. So I'll just pick a number right in between. I'm going to say the density is 2 grams per milliliter for A. Yep. That's how you do it. Now you're going to experiment and try and figure out what is the density of B, C, and D using the beakers. So I'm going to do it with you. I'm going to put A back. Now I'm going to try B. Beaker 1 sinks. Beaker 2. Let's see if it sinks or floats. Oh, wow, it actually floats. So if it floats in 1, it floats in 2, but it sinks in beaker 1. Let's look at the numbers. So I know that B sinks in 0.5 density water or liquid, but it floats in 1. So my density, I should know, try and think, sinking means it's more dense. So it's more than 0.5, but I know it floats in 1. So I know that it's less than 1. So my density here should be between those numbers. Okay? I know also if it's floating in 1, the density is going to keep going up, so it should float even more in the other two. And what I mean by that is more of the ball will be on the surface. Okay? See, let's try with C now. Let's try and figure out C's. Also, you should notice a lot of people think density just has to do with size. Not really. So even though A is a small ball, it is still more dense than B. B looks bigger, but A is more dense. The reason is because A is heavier. A is smaller, but it's heavier, so that'll make it more dense, even though it's a smaller ball than B. And C is a really big ball, but I bet it's probably not going to be as dense as A, because A was really heavy. Okay, so C, it does sink in 1. See about the others. Will it sink in 2? Yes, barely. Try it again. Oh, it's barely floating. But if you try it, yep, it does float. And if it floats in this one, it should definitely float in the last one. Okay, now, based on this information, trying to estimate the density for this one. D is a special case. I will show you what I mean. So I'm going to put C back on the shelf. Now D. D sinking. Let's check this one. Still sinking in 2. Ooh, It looks like it's almost sinking. So I'm going to see if it goes up. D is special because I push it down or up, it stays there. This one is the middle. It's not quite sinking and it's not quite floating. It stays in the middle. This is a special case. So if something is the exact same density as the fluid that it's in, or the liquid, then it'll be in the middle. It won't float and it won't sink. So I know the density for D is 1.5. Let's see this one. That one does float. Okay. Now drag objects B into beaker 2. Which object is denser? Okay, I'm gonna put these back on the shelf. Let's try this. E2, B into. Okay. So which one is denser, B or E? B is the purple one, E is the green one. Which one is more dense? Remember, more dense will be sinking or closer to sinking. So please write down which one is more dense and then how did you figure it out? When I say explain, I want the word because. Next, describe how you know which object is denser in each situation. Objects A and B are placed in beaker 1. Okay. So I'm going to put B in beaker 1, and I'm going to put A in beaker 1. Okay, based on that, which one do you think is denser? A or B? A or B? And then how do you know that? That one is that one right here. Next one, put them both in beaker 4. So I'm going to put A in beaker 4. Boom. And put B in beaker 4. Okay, now how can I tell which one is more dense? Is it A or is it B? And how did you figure it out? That was the last one. Once you do that, please take this survey. And then once you do that, you are all good to go. Thank you so much, everyone, for staying with me the whole time. Bye.